software. So now companies from Microsoft with Cisco are aiming for a piece of it. In Singapore, Upton Saidi, CNBC.
Still watching.
That's a good example of connecting all these technology with the city's infrastructure and smartly analyzing and really see the progress of these services and the infrastructure and making everything in a one cohesive system. So it's very easy to make every system efficient since it's the transport and everything is connected. But when it comes to connectivity, that smart technology is good enough, or do we have to think of the sustainability as well? Just applying the technology into existing cities where they don't run properly, how much of the efficiency that we can get in terms of sustainability? That is a question for us to answer. We think as designers, we can start things from the scratch if it is a new plot. But when it comes to an existing building, you just have to develop a new concept for it. But somehow you need to think again from the scratch. Otherwise, we will be supporting the same system, same strategies and the technologies to run down us and create a lot of issues in the future in terms of urban areas as well as in cities. And also, there will be no solution for the climate change issue as well. These are some smart buildings, design smart building for sustainable city. These are some of the ways that you can just try them. These are strategies that you can follow. And I would explain a couple of things with some examples as well. And when designers take a site into them as a project, these are the things that they have to do to make that project a sustainable project and a smart project in terms of it is sitting on a sustainable and a smart city. Otherwise, the city can have all this infrastructure which is very smart, but the buildings itself is not smart enough to handle them. The pollution and all these things will again occur, and the life inside a city would not work. So when you start designing, or when you just trying to alter the current situation of a city, you have to optimize the site potential. That is very important. The site potential in the sense you need to think of the orientation, where your country is located, which is above the equator, below the equator, and how the sun works, and from which months that you're getting the most of the sun, and the heat from which side, how do you cut them off, how do you allow the natural sunlight to come in, we call them passive strategies, how do you get the natural ventilation to come in instead of having air conditioning all the time, those things we need to think. And optimizing energy use is something that we really look into, because we consider some of the cities which are growing is using very less energy, but the cities which have grown using many times than the small cities' energy into their one day's run. So protect and conserve water is a must as well, and optimize building space and material use is also another very important thing. They have a lot of sustainability strategies involved in terms of material use as well, which is the reuse, recycle, and reduce would work, but there are some more other concepts for sustainability as well. Enhance indoor environment quality is one of the major things that we have to look into, as I explained earlier, because it's the environment that you live for 8 hours when you are at work. Optimize operation and maintenance practices is very important, because you might do a building, you might do different other spaces, urban spaces at certain cost, but then you have to think how would it be maintained, what is the energy consumption, how we can resolve the rest of the pollution issues, as well as whether that will be a magnet for the city dwellers to have a wonderful life. Trying to explain a bit more about the site potential, I would show you a project from Singapore done by Moha Architects. This is a biophilic design. I'm going to try out another concept called biomimicry as well, which architects and the designers all around the world uses. So I'll explain it to you next. And this is the biophilic building, Moha, in Singapore. Since there's no audio in the video, I just think I should explain this. The biophilic is actually attaching all these biological, bio and bio-related matters into the building and facilitate them inside the building without removing them out or keeping them away from the buildings. By doing this, you can save a lot of energy when you are shading the facades, as well as it gives a lot of mental relax for the dwellers as well as for the researchers done around the world. And you can just always go for renewable energy, as which has been shown in here. And one of the most important things is that the building should not work as wind barriers. It should let the wind flow across the cities, so it can take all the heat out of the cities as well as from one space to another and utilize the city spaces as well. So you see all these wind which could flow through the building structure, and that will ventilate automatically, and that's a passive strategy. So the building doesn't have to be fully air conditioned. Well, I'll move to the next way of approaching the same optimizing site potential, which is in biomimicry. Biomimicry is we imitate nature, we see how the nature works, and we try to imitate it and try to go with the natural process. Why we have to do it? Because nature doesn't have any waste. Nature solves its all problems by itself. So that is why engaging with the natural process is very important. The reason why I wanted to explain about the World War II and all these historical things is actually when the people start breaking away from the natural connections. The problem starts because we didn't know how to engage with the natural process and make ourselves a part of nature. So we created a lot of waste, a lot of issues by ourselves, which we cannot solve, and either the nature cannot support us to solve. But if we just try biomimicry and biofield concepts, nature can give some sort of a support for our cities and the buildings to survive and eliminate climate change causes. This is in Brazil. This house is totally packed around with the plants, and different strategies were used to irrigate it in a proper way. If the water is rainwater harvested, then it's perfectly fine because it doesn't have any cost. It doesn't have any maintenance required because the nature itself maintains its properties. And this is one of the researches we try to do in Sri Lanka. We try to get all these plot sizes and the regulations of the UDA, and we just try to see what is the best potential plot coverage, as well as against that what is the height that you can go with the plot coverage. And we felt at the end of the research, it's the biophilicness and the 50% of the property if you can cover for a building and the rest of the facades leaving the windows out, then the whole townships that we design in the future would be very biophilic, and it doesn't invite any issues like UHI, which is urban heat island, because there's no surfaces that the sunlight would fall in and heat and dissipate the heat in the evening, which is the prime cause of the urban heat island. And some more examples through biomimicry. As I explained, why biomimicry, the nature uses only energy that it needs. That's very good thing, because if you follow the nature, we can just get the thing done with a very minimum use of energy. And nature fits the form and the function. There's no excess things. Nature fits exactly for the function, and it gets it done, and it's very efficient because of that cause as well. That is why the biomimicry is very important to us as designers when we design building. Nature recycles everything as well. Nature doesn't have any waste. It recycles itself. Nature banks the diversity. It supports diversity, and it really let the lives be dependent on each other. Nature demands local expertise. That means the nature just try to work out with what is available around and how he can survive by itself. That is why different ecosystems are different in different climate regions. This is one of the examples that the biomimicry used in architecture and design. The material usage is cut down drastically by understanding the bone marrow structures and trying to mimicking them in the furniture using different materials. So the furniture could be very lightweight, but still very strong as well. And you save a lot of materials by doing this. And this is a similar example where the structure of a chair is designed with, again, a bone marrow structure and very less material, but it serves the purpose and it's efficient as well. And these are different other technological advancements that you do a lot of research and identify a whale which is having a huge weight could go through the water with those two little fins. That means vice versa, that those fins and the design of those fins are really efficient, that you can just use it for regenerating energy using wind, because wind is also fluid as we consider in terms of generation of this electricity through windmills. And optimized energy use. Optimized energy use is understood in different ways. Energy gain to be minimized first, because with the windows and the walls are the prime sources of gaining energy into a building, and those buildings are getting heated a lot if you just expose your building all around to the sun. So that is why the high rises are having humongous issues of energy, because they're just consuming a lot of energy, and if you put glass all around it, it has the greenhouse effect and it heats inside spaces, and then you need to invest a lot on air conditioning. So you need to just think of optimizing energy use as well. And to improve those energies, there are different things done in different places on the earth. In Germany, I have seen an example where they have used geothermal energy. That means that they just dig a well down and they just get that heat and heat up the water by pumping the water down and get it heated and bring them up again. And there's another building, they send the water down in the summer and bring that water up again in the winter. So you are cutting down the energy loads in the winter time, where you need a lot of heating of water during the winter. And then again, the optimized energy use can be understood by different means of facade designs as well. There are certain buildings. This building is by the UN studio, and there are different buildings in the world that the facade fenestration, the size of the opening, as well as the shading could be controlled by a centralized BMS system, and that system will let the building know which facades to be open in the morning and which to be closed in the evening. And they will get the light and the ventilation from the sites where direct sunlight is not coming into the building to cut down the heating load. And when it comes to protection and conservation of water in buildings, it's a really critical thing, because one most important thing is that actually we need to go for rainwater harvesting. We need to conserve the water by protecting what we get free of charge, and then reuse it, and think of grey water harvesting as well. And sometimes the water conservation works when it comes to geothermal energy and heating it up and recycling within the premises. And you can just use different technological gadgets as well, like faucets, WCs, and different shower nozzles, because they could save water 90% to 80% to 90%, depending on their design as well as the sensations that they generate. Most of the time, the faucets or the taps, what we call, they don't put a lot of water out these days. But what they do is they create a sensation that the water, a lot of water has come out by creating bubbles, water bubbles within the nozzles. So the water spreads when it falls into your hand very well. So you feel that a lot of water has come out to your hand and all the soap will go on. But it's very less amount of water that it used. And efficient irrigation systems when it comes to landscaping, as well as if you are having vertical gardening in the building, you definitely have a very efficient irrigation system, which is, if it is centralized, it's perfect, because the sensors can say, okay, this area the plants are having a drought and you just have to have some water, and you can have just local plants even for that, because in that condition the local plants can survive with the amount of water that they have. During that time you don't have to treat them specifically because they are local plants. And some more when it comes to optimizing building space and material usage is actually now a lot of innovations are going in terms of building materials, how much of you can do with the materials, because there are facades which can, let's say it's a facade of a huge building, and if the facade cracks, you need to have a lot of energy and a lot of effort to prepare it, and a lot of waste of materials. Now the engineers and all the researchers are trying to develop materials which can grow by itself and cover that patch, and those are used mostly with the bioorganic materials inside those. This brick is called BioBrick, and that was done by biomass company. And this is actually this was an initiative that they have started as a startup, and now they're trying to go global with it. So by doing these things, the brick could control the humidity inside the building, which why we need a lot of air conditioning. If a brick could do it by itself, then we can just use less energy for us to run the building. So which is good in terms of pollution as well as fossil fuel. We call it the carbon footprint. So the carbon on the building operations and the building would be really less. And when it goes to reusable materials like fly ashes in cement, that's also a very good thing, because it's a byproduct of another process, and you use the product into another process without using virgin materials, so you don't have to disturb the nature too much while you are constructing. And enhance indoor environmental quality, one of the important things, I have told this several times, but in this case, I would say biophilicness as well as letting the nature to come into the space and give a comfortable feeling as well as control the humidity inside the building could also be considered as a modern technology as well as a new concept of building interiors in most of the buildings. Optimize operational and maintenance practices. This is a crucial area because many buildings they build with a certain amount of a budget, and apparently what happens is those buildings to run, they need much more effort rather than the people are putting into construction. They have huge cost overruns in energy, water, as well as in all the other processes. So you need to design it in a very proper manner so you can optimize operation and the maintenance practices as well. And I'm going to show you one of the projects that we have done, and the same project that I have mentioned in CV, which is the Sustainability Authority headquarters. So you will see how we have designed this building and how we have achieved different parameters to make it an energy sustainable building. The secret of this building is actually the building is shaded throughout the year, all the facades, every single window. So there's less heat which is coming in, as well as it can flush at the night when the air is cooler, and the building when it starts in the morning it has cool air inside and very less in starting energy that is needed for air conditioning.
Building itself should set an example of a clever passive solar design. 365 days under shading. Clever use of material and systems to reach near zero carbon footprint. With the unique form for its purpose, Sustainable Energy Authority headquarters won the first place in project competition among well-established practices, expressing the capabilities and opportunities such as solar power generation, daylight, rainwater harvesting and similar environment-friendly systems. The proposed site is at Bath Taramola in the close proximity to the Sri Lankan Parliament, and the region is becoming the full-fledged administrative capital of Sri Lanka. Cantilevering out building form and the facade elements are designed to welcome the natural ventilation in moderated levels. Furthermore, to avoid the microclimate air getting heated, the driveway paving is a combination of soft and the hard landscaping. Central courtyard as well improves the air circulation, and the wind turbine support the stack effect by extracting out the heated air in the courtyard. Building form is invented to receive no direct sunlight. Interior is shaded throughout the year. Leaning building form, cantilevering floors and the vertical fins ensures solar shading throughout the year at any day. According to the analysis by LJ Energy, referring Building Energy Benchmarking Report 2017 by BCA Singapore, energy user index of an efficient small office building ranges from 120 to 140 kilowatt-hours per square meter per year. The estimated energy user index of proposed SLSEA headquarters building without parking spaces considered is 80 kilowatt-hours per square meters per year, and with parking spaces considered it is 53.4 kilowatt-hours per square meter per year. Basement is used for the effective stack parking and to contain all the mechanical equipment required for the air conditioning, water recycling and electricity supplying. Space is naturally ventilated and lit through the central courtyard. Minimum human circulation paths in the building, percentage of circulation spaces as a proportion to the built-up area, 12.1%. As a passive strategy, the ramp which connects all floors creates an informative avenue with interactive user interface, which improves the knowledge among the visitors regarding the opportunities and potentials of clean energy. Further, these access are having the potential for dedicating for different user categories depending on the need of access. This avoids congestion in circulation spaces. Interior design is to maximize the daylight harvesting while arranging the spaces in a radial manner with light color themes. Since most of the spaces in the building is lit through daylight, the artificial lighting to be considered only for additional working hours and to respond to the climatic variations. At these times the interior will be lit with low-energy task lights for the required areas to minimize the energy demand. Exhibition space at terrace level, which improves the knowledge among the visitors regarding the opportunities and potentials of clean energy. Animated wind turbine energy element for demonstration purposes as well as a live object which connects all the floors and even the terrace level exhibition space. West-facing ramp. As a passive strategy, the ramp which connects all floors creates an informative avenue with interactive user interface, which improves the knowledge among the visitors regarding the opportunities and potentials of clean energy. West facade heat barrier. To avoid sun, a green solar paneled facade has been introduced covering the facade as well as to invest on the amount of solar energy falling into the facade. Leaning building facade. Each facade has its unique leaning angle catering to shaded spaces from above floor slabs depending on the solar angle. Vertical fins are windows. Fins are to cut off direct sunlight, and window fabrication is with low E-value fabrication systems which are automated and climatically controlled. All full-portion spaces will be air-conditioned. Basements, toilets and mechanical room will be mechanically ventilated and all other spaces naturally cross-ventilated with draft and stack effects. The building shall use construction material having low embedded energy and materials produced by environmentally sound methods, which will emit the least amount of harmful gases and waste. Without differentiating between the natural environment and the built environment, the building will feature the possibility of becoming a part of the natural environment by blending with the surrounding vegetation and soil structures. Green power or self-containment. The building will attempt to use natural lighting and ventilation and to generate own green power as much as possible, so that there will be marginal exchange of energy between the outside and the building. The building will use very little external energy and will make the maximum use of the resource by employing the latest efficient technologies. Use of utility water and other material resources will be kept to a minimum by employing technologies such as rainwater harvesting, recycling and reclaiming of waste generated by the occupants. The proposed building could employ a state-of-the-art building management and access control system including occupancy sensors etc. to keep the energy demand to a minimum.
Excuse me, Mr. Suresh, you are muted.
Sorry for that.
Okay, thank you.
And concluding my presentation, I wish to inform that there are a lot of advancements in software as well these days. The softwares could manage the building while it is designed, as well as it could be managed its new design forms and new design elements and do the simulations for energy as well as for structural compatibility and come up with new strategies for saving materials as well as for less energy use. So most of the times, currently the world is going towards the biomimicry and biofluidic designs because people who are now understand that though we just try to separate ourselves, we just have to go along with the nature so that we can learn from it and we can apply the same strategies that the nature applies and then we can solve a lot of issues. That is the future in building industry as well as the modern technology which goes with the biomimicry. I conclude my presentation. Thank you very much.
Thank you very much, Mr. Suresh. Thank you very much for very impressive and very interesting presentation. And now I will open the door for the questions. I am sure the audience may have questions. So let's start the panel discussion now. Let's open the door for the audience. So if there are questions from the audience, you are very welcome. So please bring your questions to Mr. Suresh now. Well, I will start asking some questions then. Mr. Suresh, you mentioned about the use of geothermal energy for buildings. How do you see the potential of use of geothermal energy in Sri Lanka?
I'm not quite sure how I can answer that question, but I can share one of my experience with you. And I was happened to be in Germany in 2019 under a German program where they have just explained us everything about how the geothermal energy works in their country because they could use it because they have a super winter and a super summer as well. But we have not, I don't think, I have not come across any of the researches that we have done. If we do a proper research and if we can establish or ensure that that will work, maybe that's a possibility for us as well.
Thank you very much, Mr. Suresh. Any other questions from the audience? Well, you showed the building that will be used by Sri Lankan Sustainable Energy Authority. for that building, when you are constructing or when you are recommending or when you are giving the instructions, do you recommend any recyclable material for the construction, or you are using, how do you minimize the carbon footprint of the materials?
Carbon footprint of the material, it's a market driven thing. So I wish to go with all these bricks, which is like less carbon footprint and everything. But when it comes to engineering practices and different other requirements by the client, there are certain limits that we have, but we are just going for local bricks, as well as sometimes we just actually specified the cement with fly ash, which is really a engagement that we can do because it's in the standards as well, so we can just directly do that. And we just try to eliminate. I'll explain it in a different manner. How do we cut down the carbon footprint? And when it comes to glasses, it was suggested for the thermal performance that we need to go for double leaf with a gap in between for all the facades to get more thermal resistance. But with the simulation that we done with LG Energy in Singapore, it was suggested to us that it's not necessary to go for two leaves. And because of the shape of the building itself, you could have minimized a lot of glasses. So I think in that way we have contributed to the carbon footprint of the building. But otherwise, frankly, most of the materials which is available in Sri Lanka will not go into that grade of less carbon footprint. But still, always we try to use steel and everything which is recycled and optimize the design to reduce the consumption of the materials.
Thank you very much, Suresh. I have one more point. How are you going to recycle the water, the rainwater? Do you have any special mechanisms?
Actually, what we did is, if you could see the presentation still, or otherwise I can share this. Let me share this. Do you see a tank around the courtyard?
Well, yes.
Which is
yes,
over
correct.
here? Yeah.
Yes, correct.
So that is the rainwater tank that we have. We are just taking the water down through the gravity, and we have just used only a sand filter because we are using it only for flushing washrooms. And then at the basement, we do have a treatment plant for sewer as well as for water, and we were allocated the space, and we gave one design for that. And that needs to be finalized with the client while it's in the construction.
So all the water fall into the roof will be collected to this this tank. Am I correct?
Correct.
Okay, that's nice. Okay.
We have a capacity of 20,000 for drinking water and 80,000 for fire, plus another 20,000 liters as water harvesting.
Okay, so it's like when it is raining, it's almost like a swimming pool. Am I correct?
No. That water will not stagnate in the roof area where you will see it in the green, but that will slope down into those into the tank, which is just over here.
Okay.
And it works like a bucket. It's not. Yes, it is coming up from the floor, but still it has a profile which goes down also, so the water can just come and gravitationally go into that tip, and then the water will be taken through a duct through a sand film.
All right. Okay, got it. Thank you very much, Mr. Shri. Well, let's see whether we have a question.
Mr. Suresh, I have a question. Actually, I can see a lot of vertical gardening in this building. Is it popular in our country, or what are the limitations that we are having to introduce vertical gardening systems and the vertical and the horizontal gardening systems in our buildings? Is there too much of limitations? Because I can see that there are very less buildings who are using, especially the vertical gardening systems.
Okay, I agree with you, and I'll tell you why we have used this vertical garden. If we could avoid it, maybe we could have, but we didn't for a reason. The reason is this facade is facing west, which is the most energy gaining facade of a building, which is the western facade. So what we did is, actually we know none of the trees are getting heated when it is at daytime. How much of a summer it is, the trees are not getting heated.
Yeah.
Because it has its biological ways of cooling down itself, and we use the same thing into the facade, and we just covered it with plants, and there's no heat that will transfer into the building with conduction. And there's another buffer in between the gardening and the wall.
Yes.
That is the ramp which was there. And but I agree with you on the vertical garden matter. If you use local plants, and if we investigate how we just can use a local plants in this area, I think we have specified some of the plants. I'm sorry, I cannot really remember them. But if you want, I can just share the details with you. And we just have to think of the locality which was mentioned in the presentation earlier. If you use the same plants in your landscape and even the vertical gardens locally, then within that context it could survive. But most of the time what happens, we go for vertical gardening and we select plants which looks nice. And then it doesn't work. Some of the creepers would work in this manner.
Yeah.
Some of the local, like you have seen a lot of, I think the same thing in the concept of biomimicry goes in here. When a mountain is sitting in the city, if it is totally covered with grass or whatever the plants could grow around itself, the boulder will not get heated up because the plants are covering it. But why can't the same thing happen in the building if you select a proper plant? So it is possible, but we need to have the proper strategy and do a bit of research and apply it in the correct way.
And Mr. Suresh, is it possible that with even though the vertical gardening system is not popular, if we can introduce vertical agriculture systems, the food, will it be like, do you have any idea about that such scenario in Sri Lanka?
I think it happens in the same manner. What I suggest is, if you want to do something like that, please try to see what grows in that area naturally.
Okay.
You cannot force for agricultural plants, or whether it's for gardening or whether it's a wild plant. I don't think that we have a choice there, because the nature has to choose it by itself and let those plants survive under the circumstances that the nature could provide in that context. So that is where we are going wrong in terms of vertical gardens and in most of the lawns and the landscapes as well, I guess.
Okay. Thank you, Mr. Suresh. Thank you.
Any more questions from the audience? Okay, looks like we don't have any questions, more questions. Then thank you very much, Mr. Suresh, for your time and the dedications that you have shown for this presentation, and we appreciate it very much. And we wish you all the best for your future projects. And with that, we will conclude our workshop sessions.
Thank you very much. It's an honor to have me here. So I take this honor for myself, and thank you so much for inviting me.
Thank you.
Thank you very much, Mr. Suresh. So I will end up the session, and thank you very much. Thank you very much for your the kind cooperation and also consuming a valuable time. Thanks a lot again.
Thank you.